Alright, hello. You may notice that this video is not in the classroom. This is in Dr. Gopal's office. That's because whenever I was starting to edit the Zoom video, I noticed I was from the perspective of that weird upward facing mic the entire time. So it's basically completely useless, that footage, unfortunately. So I'm just gonna redo what we talked about today quickly in this little video here. So I'm just going to go ahead and start. Here's our brain again. We're going to start again with the longitudinal fissure. It's not labeled explicitly on here, but it's pretty easy to see from here. It separates the two hemispheres by that longitudinal fissure, or called the deep sulcus. We also have at number 20 here. And right here we have our central sulcus, which is a dividing line for our frontal lobe, and also from a frontal lobe from a parietal lobe. It also separates the primary motor from the primary sensory cortexes, so that's important. We also have the Silvian fissure at 28. You can see it right there, and that separates the frontal from the temporal lobe. It's also known as the transverse fissure or the lateral cerebral fissure. I'm going to call it the transverse or Silvian. That's just the terms I know best. Starting back to the lobes, number 2 here labels the frontal lobe. It's responsible for logical thought, creativity, spatial knowledge, language, emotion, motor control. You can see that motor control area is also represented by this 1A here. Our boundaries include that central sulcus we talked about, the Silvian fissure, as well as the longitudinal fissure. And it houses the anterior central gyrus, which is marked by number 10 here, also known as the precentral gyrus. And that separates the primary motor cortex from other parts of the frontal lobe, as we'll see, such as the superior frontal gyrus, the middle frontal gyrus 8 here, and the inferior frontal gyrus right here, which houses Broca's area, responsible for motor speech in that area. And again, that precentral sulcus, actually, forgive me, I was saying the precentral gyrus is right here at 10. The precentral sulcus is number 19 here. And that's actually where the rest of the frontal lobe separate from the primary motor cortex. I apologize, that was incorrect. All right. Got ahead of myself. So here's number 4, represents the parietal lobe here. It's responsible for sensory information, and it houses the posterior central gyrus, also known as the primary sensory cortex. That's number 11 here. Also known as the primary sensory area in our coding, which is this 1B as well. You can also just see it's pretty clearly labeled in this purple, this darker purple compared to this lighter on the rest of the parietal lobe. The primary sensory cortex is separated from the rest of the parietal lobe via the post-central sulcus. That's this 21 here. So you can see how in this model, it's also good separator from the lighter shade of purple from this darker shade. If I knew more about colors, I would say the specific color, but I'm not that in depth, I guess. So in 22, we have the intraparietal sulcus over here, mother major sulci of the parietal lobe. And we also have and talking about the parietal lobe's boundaries, this boundary includes that central sulcus again, as well as transverse and longitudinal fissures. So we're still being separated by those major ones. And we also have the parietal occipital fissure, which we can see at 25 here. Right there. Yep. And that kind of separates out the parietal lobe from the occipital lobe, hence the name parietal occipital fissure. And we're going to go ahead and talk briefly about the occipital lobe. Primary for visual, it houses our occipital visual cortex. So for visual information, so we're not going to talk about it that much in depth. It has superior and inferior gyrus that's separated by the lateral occipital sulcus, which can be seen in this 24 right here, also known as the calciferin sulcus. So you have that kind of inferior and posterior part, superior, I should say. All right, so now we're going to go over to the temporal lobe, number 3 here. Temporal lobe is responsible for visual memory, language comprehension, and auditory processing via the primary auditory cortex, which is our big glowing red area here. Very important. Boundaries are the parietal occipital fissure at 25 here, as well as the transverse fissure, most prominent one. Includes some couple gyri here, including the 15. We have the superior temporal gyrus, which is for auditory memory. Our middle, which is over here, not quite in the middle of these gyri. Number 16, the middle temporal gyrus, is for language processing. And we have 17 over here, which is the inferior temporal gyrus, which is understood for understanding some written languages. Before we take this brain apart, while we're still on the surface, briefly, number 6 is, of course, our cerebellum, responsible for balance, among other things. I'm just going to go ahead and open this bad boy up real quick. And I'm going to show you, if I can find it, here it is, another part of the temporal lobe real quick before we move on. It is, I can't find my pen. The 79 right here. That is our uncus. It houses the amygdaloid complex, supposedly responsible for giving emotional value to sensory information. So right there, the uncus, you can kind of see it's underneath. It's still part of that temporal lobe. So now I'm going to get the other half for the rest. And you can also notice that when we do the brain like this, we're doing it in a sagittal cut, when it's right down the middle like that. So we're going to use this half, the left hemisphere, for the rest, for a good chunk of our labeling now. 41, we have the corpus callosum, responsible for linking together the cerebral hemispheres. So it's not, in real life, we don't really use these pegs. We use this corpus callosum to get those together. We also, if we come over here to the superior side, we have 42 here, which is the genu. It's an anterior bend. You can notice that has that bend that connects the medial and lateral surfaces of the frontal lobe. We also, in the back, the posterior side of the corpus callosum, we will see the splenium, that's how you say it, which communicates with the parietal and occipital lobes. As you can see, because it's kind of in that proximal area. Next, we're going to move on to number 49 here. Almost fell, didn't quite. Oh, there we go. So, number 49 is the thalamus. Relays sensory information from visual, auditory, so much of sensory and gustatory senses. We also have memory, arousal, motor activity, and emotions controlled through our thalamus. Now, obviously, there's other parts of the thalamus. There's like your subthalamus and hypothalamus. But since we're doing this kind of scale model, this is pretty much as much detail as we're going to get into right now for the thalamus. Just this general area. We can't really break it down much more using this model. But we are going to, before we break out of this entirely though, we're going to point out the penal gland right here at 54. And what that does is that's our big hormonal area for things like serotonin, melatonin, big hormonal area. We're also going to move down to 56. There we go, where you can see the quadrigeminal bodies. And these are our Colliculi pairs. They're not paired up right now, so it's just one of each. Our inferior and superior. Superior is for visual information, inferior is for auditory information. So I'm going to get those paired up later so you can get a better view of how that works when we get more detail on that. But I'm going to go and talk more about the brainstem now. So with the brainstem, we have, starting at 63 here, we have the Medulla Oblongata, which is connecting up from the spinal cord. Imagine that coming up from here. We're officially approaching the brainstem once we hit that medulla, which works with those autonomic functions. We move up to this little bulb here, which is 65. You can kind of see how it's kind of bulbous out from here too, from that perspective. And that's our pons. We have the pontine nuclei, which is useful for motor memory in this department. If we move up again, we'll see number 67, the cerebral peduncle. The cerebral peduncle connects the cerebellum to the brainstem using 3 parts: the superior, middle, and inferior. So the superior connects the cerebellum to the midbrain. The middle connects the cerebellum to the pons, and the inferior connects it to the medulla and spinal cord. So that's how those 3 parts of the peduncle connect the cerebellum to the brainstem. Now we're done with this part of the brain. So I'm going to get this next part here ready. It's this. I'm just going to open up this area. We're going to talk about that later. I'm just going to go ahead and get rid of this brainstem area. We're going to talk about that later as well. We're going to start just with this little insular part of the brain. So if we take the brainstem out, we're going to see at this number 80 here, we see right there the internal capsule, this little strip here. You can kind of see ring kind of going around. What that internal capsule does is it sends information to and from the cerebral cortex and basal ganglia, which, basal ganglia part of the in that thalamus area in terms of that auditory pathway. If we also see the inferior surface of the corpus callosum at 83. You can see like the corpus callosum we saw earlier in the figure, it has that ridged kind of surface. We also can see, if we look at from this perspective, we can see the 86 and 84, those representing part of the insular lobe and the gyri of the insular lobe. So it's kind of that part where you can see where you have to hang. There's that one graph we have to kind of have the brain pried open to see the insular lobe. So that's kind of how we have to get everything all opened up before we can even look at it. And again, we don't really know a lot about what the insular lobe is responsible for, but we know it's right over there. So before I get to the very end of my brainstem, there we go. I just want to briefly get these two connected. Here we go. All right. And I have the full brainstem here, how it would look. And I just want to point out the cranial nerves real quick. The way this figure works is that both sides are labeled kind of differently, one with the traditional numbers on the key and the other with the Roman numerals. So if you see here, we have like cranial nerve 1, olfactory, 2, we have the tragus over here. Yeah, that's tragus. Relevant one that we're talking about today is cranial nerve, there we go, cranial nerve 8, right there. Our vestibular cochlear nerve here, you can see it's the same kind of nerve right there, 120, right there. I don't know if we've gone over the auditory pathway, if you guys have or not, but that's an essential part of the auditory pathway, is going through, for each ear, is going through its respective vestibular cochlear nerve. Also important is the facial nerve, which is cranial nerve 7. I don't know if you guys have gotten to that either yet, but just know that that's there too. And that's all we're going to get into for cranial nerves right now, but it's important just to have those in your thoughts. Let me see. Take this, and now I'm just going to have the brainstem now to finish us off. So with the brainstem, we're going to start with 97 here. That's corona radiata. These little fibers are from the internal capsule and radiate from it. So we can see how how the internal capsule, as we know, sends information to and from the cerebral cortex. So the corona radiata is, oh, I'm not really in frame, there we go. Assists in that with the radiating fibers. If we turn it around, we can see number 98, the caudate nucleus, right here, yeah, right there. Part of the basal nuclei, controlling some motor and behavioral functions like posture. And then if we go, all right, quick cut because I had a phone call. Sorry about that. Wrapping up here, we have 102, 101, 100 and 101, which are the superior and inferior colliculi right here, 100 and 101. And if we get these connected, you can kind of get a better view right there, yeah, of how they're paired. So you have a pair of the superior, pair of the inferior. Remember, inferior is doing our auditory here. Superior here is doing our visual. And last, we're going to talk about is 102, which is our medial geniculate body, right here. And what that does is it takes information from the inferior colliculus and transmits it to the auditory cortex. So you can see how it takes information from the inferior colliculi, goes from here and then up all the way to our auditory cortex, this red area here. So you can kind of imagine how sound travels, you know, from our cranial nerve all the way towards up that you can see kind of how it travels from our cochlear nerve all the way up, all these little processes in between. Yeah, with that internal capsule, here we are. Things like that. And that's all I got for the brain. If you guys need anything, you know to email me. Otherwise, that's it. So I'm going to end the video. See ya on Fridays.